Alright, hi everyone, and welcome to PreCalculus 11, where we're going to learn about 3.3 special angles. Did anybody else notice the PreCalculus title? It's supposed to be PreCalculus. Hello. Anyways, I'm just kidding. Sometimes I just throw things in there to see if anybody's paying attention. And Calculon, by the way, is the robot in Futurama that's on the soap opera that I really like that show, by the way. It's a really awesome show. Anyways, let's get straight to it, and don't be too alarmed because your notes look slightly different from mine only because I'm trying to make things look bigger on the screen so you can see it on your little tiny devices. So here we go. Let's construct a couple special angle triangles. Now, let's create a 45 degree triangle, which is basically a right triangle, right? And each side is going to be side length 1. So let's draw it like this. Wow, this is amazing. This is 1, and this is 1, and this is root 2. Oh, how did I get root 2, by the way? Sorry, I should show all my work. Well, since this is a 90 degree triangle, and we're doing Pythagoras, we're using Pythagoras to figure that out. The hypotenuse, 1 squared plus 1 squared, and square root of that is square root of 2. So here's my picture, and here are the angles, 45 degrees and 45 degrees. Okay, so that's our first special angle triangle, basically 45, 90 triangle. And the second one, I am going to draw an equilateral triangle. Okay, like this. Each side is, each angle is 60 degrees, right? Because equilateral triangle means all angles are equal. And each side, let's just say they are 2, 2, and 2. Now suppose I were to cut this in half. Let's say I cut this straight down the middle because I don't have 90 degrees yet. Oh, but now I do. So this is 90 degrees, and this side becomes 1. This side becomes 1. And that height of that triangle, I suppose I could figure it out by using Pythagoras. So let's go 2 squared minus 1 squared, and the square root of that is the height, which is root 3. So this here is root 3. And lastly, I've actually bisected this angle up here into 2. So that's 30 degrees. Now let me just clean this up a bit. Give me 1 second. Ding! Okay, so you should get something like this. So I've just cleaned up a little bit, and these are really handy because you could figure out the sine, cosine, tangent ratios in all 4 quadrants of these reference angles. So 45 degrees, let's figure it out here. So let's say that 45 degrees reference angle is in quadrant 1. So there's 45 degrees, there's my reference angle, right? They're all, but specifically it's 45 degrees in quadrant 1. And then let's figure out what these measurements are. So based on this triangle up here, let's just color it in, this one up here, then I'm going to label, well that's 45, the other angle is also 45, it just happens to be, and then this is 1, and the hypotenuse is root 2. So I could basically figure out sine, cosine, tangent of 45 degrees in quadrant 1. Now, what about reference angle of 45 degrees in quadrant 2? Now, if it's reference angle 45 degrees, the angle in standard position is 180 minus 45 degrees, which is 135 degrees. So in quadrant 2, the reference angle is 45 degrees. And here, you be careful, okay, this is 45. The hypotenuse is root 2. This adjacent side is negative 1 because of the position of where x is, and this one here is positive 1. Okay, and then we just keep going around. Let's find another reference angle of 45 degrees. Now, oops, it's really wonky there. It's in quadrant 3. Now, what is that angle actually in standard position? It's 180 plus 45 degrees, which is 225 degrees. Okay, now let's figure out all these measurements. Well, the adjacent side is negative 1. This side down here is negative 1 because, it just is. And this one here is root 2. Okay, and one more. Suppose that we have our reference angle in quadrant 4 is 45 degrees. I already have the adjacent side is 1. This is negative 1. And the hypotenuse is root 2. And what is this angle in standard position? It is 360 minus 45 degrees, which is 315 degrees. Okay, let's do the same thing now for reference angle of 30 degrees, okay, and 60 degrees. So suppose let's just draw this out here. Let's draw these. Yeah, let's just do it like this. So these are all 30 degrees. All the reference angles are 30 degrees. Okay, let's figure out what they are in standard position though. In quadrant 2, 180 minus 30 is 150 degrees. In quadrant 3, 180 plus 30 degrees is 210 degrees. And in quadrant 4 is 360 minus 30 degrees, which is 330 degrees. Okay, so let's figure out what all these lengths are and stuff. Okay, so our hypotenuse in this other triangle, let's shade it in now over here, is always 2. So let's label 2 everywhere. So this is 2, this is 2, this is 2, and that is 2. Okay? Now, the, let's see, what is this? This is, let's see. Okay, so this is 30 degrees. The reference angle is 30 degrees, and there's 90 degrees. So let's look on the triangle here. What's the side length that is between 30 degrees and 90 degrees? And I look, 30 degrees is up here, 90 degrees is down here. The side length is in between, is right here, is root 3. So root 3 I'm going to put right here. That's root 3, that side length. And this one here is negative root 3. It's kind of squishy. Oops. Okay, so that's all I really have for my x's, just positive root 3 and negative root 3. And then the opposite, the other missing side is 1. So this here is going to be 1. This here is going to be 1. This here is going to be minus 1 because it goes downwards, right? And then this is also minus 1. Okay, let's do the same thing for reference angle 60 degrees. It's going to look kind of ugly though, so 60 degrees is a little bit more than let's just say it looks like this. Okay, like it's going to look really flat like this. Or not flat, but very steep. So that's 60, right? All the reference angles here are 60 degrees, so 60, 60, 60. So these angles in standard position, well, the first quadrant is 60 degrees. Second quadrant is 180 minus 60, which is 120 degrees. In quadrant 3, 180 plus 60 degrees is 240 degrees. And in quadrant 4, well, 360 minus 360 minus 60 degrees is 300 degrees. So all these angles here have a reference angle 60 degrees. Okay, now let's figure out the side lengths. Again, hypotenuse is all 2, right? 2 in the picture. Just look at the triangle above. 2, 2, 2, 2. And let's see here. This is now 60 degrees and 90 degrees. What's the side length here? So I look on the picture, the triangle up there, between 60 degrees and 90 degrees, it's side length 1. 1 right there. So let's put this in red so it's easy to see. This is 1. That side length right there is 1. And this side length, ooh, it's so squishy to write, is negative 1 right there. Okay, and up here, I guess, is going to be root 3. And positive root 3. And then down here is negative root 3. Down here is also negative root 3. Okay, so these triangles are really handy to, you'll see in a second. Okay, so we've just derived and taken a look at all the different angles here with reference angles 45 degrees, 30 degrees, and 60 degrees. Okay, let's move on. So there are some more special angles, and when we say special, it means that you should technically be able to figure out these ratios without using a calculator, So let's see these other ones, these other special angles, and then let's use blue. I didn't use blue yet. So these are what we call I see Q and I see quadrantal angles. And just as the name suggests, what is quadrantal? It just means angles that lie on the borders of the quadrants. Okay, so for example, things like 0 degrees. What's the reference angle for 0 degrees? Well, it just lies on that border between quadrants 1 and 4. That is just that straight line right there. So it's hard to kind of imagine what sine, cosine, tangent of those angles are. So it's best to really use a graph. And I like to teach it using graphs of sine theta and cos theta, which are, it's not too difficult to derive. You just follow my instructions here and you're good to go. So remember this, y equals sine theta. By the way, this is theta, and this is y equals sine theta, right? Your axes. So it starts, ends, and the middle is at 0. Okay? Oops, and then you ignore this stuff because this is supposed to be gone. And that was the wrong formatting thing. Okay, so let's draw this. So it starts at 0, it ends at 0 at 360, and then the middle, 180, is also 0. Okay, and then it says the graph goes up and then it goes down. Okay, so it goes up at 90 degrees, it goes up to 1. And then it goes down to 180, and then at 270 it goes down to -1. Okay, so if we were to connect these, let's see if we can connect this. It's a smooth, like, oops, it's a very smooth graph. So I'm going to pause this so you don't have to watch me flail through, but let's connect these. Ta-da! Alright, so there's my graph. So this is kind of neat because this graph can tell me some information about sine. When the sine is at the quadrantal angles. Quadrantal angles are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. They're all on the border of when you're going around in these quadrant picture thingamajigs. Okay, so if I ask you what is sine of 0 degrees, well, you just look at the graph. So let's fill this in. I don't have space. Okay, whatever. Let's just figure this out. The other graph first, cosine, and then we'll figure out the rest of the stuff here. Okay, so for the graph of y equals cosine theta, it starts and it ends at 1. Okay, so it starts at 1 and it ends at 1. Okay, and by the way, this is theta, and then this is y. The y-axis is y equals cos theta. Okay, and then the middle is, what is the middle? Middle is negative 1. I should probably use a different color here. Middle is negative 1. Okay, so negative 1 is over here. So the middle between, where these points are, starts at 1, ends at 1, and the middle in between here is at negative 1. And then it goes, so this graph goes down, and then it goes up. So it's kind of opposite of the sine graph a little bit. So it goes down, so from 1, it goes down to negative 1. But in between that, at 90 degrees, it's going to be at 0. And so is at 270. Okay, and then we're going to connect these dots. So give me again a second to do this. Let me pause. Ta-da! Okay, so there's my graph. They kind of look the same, but not quite. There's sort of this like kind of curvy, and they actually are the same graph, just shifted over a little bit. So according to the above graphs, let's figure this out. Sine 0 degrees. What is the y value when x is equal to 0? If x equals 0 or theta equals 0, then sine of 0 is just, well, it's right here, is still just 0. So the answer is 0. Sine 0 degrees is 0. The ratio of opposite over hypotenuse is 0. What about sine of 90 degrees? Well, if the theta is 90, then the y value is up here, it's 1. That was easy. What about 180? Sine of 180, well, if theta is 180, what is sine of 180? Well, it's just down here, it's 0. And then what about sine 270 degrees? Well, if theta is 270, then the y value is negative 1. And last thing is, if theta is 360, then sine of 360 is 0. Okay, so you can figure out these answers fairly quickly just looking at the graph without having to draw anything else, just the graphs. Now let's do cosine. So cosine's up here, and cosine 0 degrees is 1. Cosine of 90 is 0. Cosine of 180 is negative 1. Cosine of 270 is 0. And cosine of 360 is 1. Okay, so everyone should be able to figure out sine, cosine, tangent, at least at this point, sine and cosine of 0, 90, 180, 270, 360, just by drawing these two graphs here. Okay? Now, you're probably asking, well, what about tangent, Ms. Shang? You must be kind of lonely being tangent. And I say, yes, that is true. Well, the graph is a bit tricky to draw for tangent. It's not as nice as sine and cosine, so I'm going to teach you something, kind of a shortcut or something, whatever you want to call it, a different way. Here's the identity. Here's an identity. Tangent theta is equal to sine theta over cos theta. It's true. This is always true. Okay, it's an identity. It's like, it's true no matter what. It's just an identity, meaning, it's equal to the same thing. Like, it's just always like that. It's like saying Superman is equal to, is it Clark Kent or something like that? Is his name Clark Kent? So Clark Kent is equal to Superman because that's his identity. It's just, they may look a little bit different, but they're really the same. So I'll show you the proof of that. If you're saying, Miss Yang, that's whack, I don't believe you, show us the proof. And I say, okay, here it goes. So here's the proof. The proof is like this. So we start off with tangent theta equals sine theta over cos theta, and let's just see here. Well, let's figure out what is sine theta really equal to in terms of SOHCAHTOA or SOHCAHTOA, right? Sounds like SOHCAHTOA. Well, sine theta is equal to opposite over hypotenuse. Let's go like that. And then over cosine theta is adjacent over hypotenuse. Okay, now this is kind of messy. Nobody likes fractions on top of fractions, also known as complex fractions. So we're going to rewrite it as opposite over hypotenuse, and then write it as divided by adjacent over hypotenuse. And nobody likes to divide with fractions, so we always take this and we flip the second fraction, change this to multiply. This is hypotenuse over adjacent, and well, guess what? What do you know? Well, something interesting happens here. You'll notice that the hypotenuses will cancel out, and what do we get? Well, we're left with opposite over adjacent, which happens to be tangent theta. So that's the proof that it is true that tangent theta is equal to sine theta over cos theta, and just in case you don't believe me. So now everybody's a believer, right? Okay. All right, so what does that mean for calculating tangent theta and when theta is 0, 90, 180, 270, or 360? Well, all it means is this. Well, the identity just says this. Well, tangent 0 degrees is the same thing as sine 0 over cos 0. So how do I know what sine and cos of those numbers are? Well, we just look up here. Let's take a look. Sine 0 was 0, and cos 0 was 1. So this is 0 over 1, which is equal to 0. So there's my first answer. You're going to do the same thing for the rest of these, 1, 2, 3, 4. So go ahead and do that while I pause. Go ahead and pause. Did you pause? Pause. Ding! So this is what you should get. Tangent 0 is 0 degrees. Tangent 90 degrees is 1 over 0, which is equal to Saturn. I mean, a known solution, because you can't divide by 0. Tangent 180 is equal to 0. Tangent 270 degrees is equal to undefined. Tangent 360 degrees is equal to 0. Okay, so just using the identity alone, that's how we did that. Alright, now with all these special angles and without a calculator, we can find exact ratios of sine, cosine, tangent of all the angles that we've just looked at. All these special angles being 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300 degrees, 315, and 330 degrees. So, basically, we're able to figure out the exact ratios of these because these angles have reference angles of either. Well, what did we just figure out in the beginning? We figured out, well, we had 45 degrees. We had 30 degrees. We also had 60 degrees. And we also had, what was the other ones? Let me just check 1 second. Oh yeah, got it, remember. So, or 0 degrees, or 90 degrees. So these are the quadrantal angles, 0 or 90 degrees, or those special angle triangles, 45, 30, 60 degrees. Okay. So let's move on. Example 1. Without a calculator, evaluate the sine of 300 degrees, cosine 300 degrees, and tangent of 300 degrees. So what you want to do is you want to draw where this angle occurs. This is let's see, 300 degrees occurs in quadrant 1, 2, 3, this quadrant here, quadrant 4. And let's figure out what the reference angle is going to be. If it's 300, that means it goes like this. Oops. Something like this. So this is 300, right? So that's 300 degrees. And that means our reference angle is going to be 60 degrees. Ooh, 60 degrees. So it's a special angle triangle for sure. Okay, remember from that picture, let's go here to my special angle triangles here. So 60 degrees, the hypotenuse is 2, so we'll write 2 here. 2. And the sides here, okay, let's figure this out. Between 60 degrees and 90 degrees, between 60 degrees and 90 degrees, the side is 1. The side is 1. And then this one here, opposite side, has to be root 3, but not just root 3, it has to be negative root 3. So what is sine of 300 degrees? Well, sine of 300 degrees is the same thing as sine of 60 degrees in quadrant 4. So really, sine of 300 degrees is equal to this. Well, opposite over hypotenuse, which is, in this case, opposite is negative root 3 over hypotenuse, which is 2. Okay, so sine of 300 degrees, without a calculator, is this. Okay, now let's do cosine. Cosine of 300 degrees is the same thing as cosine of 60 degrees in quadrant 4. So the cosine is equal to adjacent over hypotenuse, right, which is 1 over 2. Okay, so cosine 300 is 1 over 2. And you don't believe me? You can double check with your calculator. Just go punch in cosine of 300 and you should get half. Now tangent of 300 degrees is basically opposite over adjacent, which is negative root 3 over 1, which is just negative root 3. Okay, so those are your 3 trig ratios with reference angle 60 degrees in quadrant 4. Okay, so why don't you go ahead and do B while I pause and write the solution. Go ahead, don't be shy. Bam! Okay, so these are the answers for B. You notice that if you draw at 135 degrees, it's in quadrant 2. The reference angle is 45 degrees. And then you look at your special angle triangles of 45, 45, 90 degrees. And you slot in all those sides and make sure you got the negative on the negative x-axis there. And then you figure out sine, cosine, tangent from that reference angle. And so you should get sine 135 is 1 over root 2, cos 135 is negative 1 over root 2, and tangent 135 degrees is negative 1. Okay, let's move along. So, what is this? C. Figure out sine of 180, cos of 180, tangent 180. Now this is, the reference angle is going to be, I guess, 0 degrees. So I can't draw the picture. I can only use the graph. So let's use the graph. And so we're going to go like this. So sine of 180 is equal to, well, based on those beautiful curves here, sine 180 is 0. So this is 0. That's done. Boom. Cosine 180 degrees is negative 1. Boom. Done. And tangent 180, remember, is sine 180 over cos 180. So the answer is 0 over negative 1, which is equal to 0. Boom. So that's tangent of 180 degrees. Okay, so that's it. All right, let's move along. Example 2. Find all angles such that the theta is between 0 and 360 degrees. Okay, I love these questions. I love these questions. Again, I probably have to use the special angle triangles, so I will look here. Have a look here. Okay, so cosine theta is 1 over root 2. Now remember that cosine is adjacent over hypotenuse. Okay, adjacent over hypotenuse. And also recognize that this is positive. Remember, where is cosine positive? All students take cookies. So cosine is positive here and here. So that means in our picture, we should probably have, let's just draw a picture. We're going to have basically, just draw a random triangle kind of thing. It's got to be in quadrants 1 and quadrant 4, because that's where cosine is positive. And it says here that our adjacent side is 1, so this is going to be 1 here. Oops, I don't like that color. Let's change it because I need it to be clear. So that's 1, and the hypotenuse is the root 2, and this is the root 2. And I suppose I could use Pythagoras to figure out the missing side, or I could just look on the special triangles and figure out which reference angle has adjacent over hypotenuse being 1 over root 2. Well, I look at the triangles, and I know for sure it's not this 30, 60, 90 triangle, because there's no root 2 in there at all. So it's definitely going to be 45, 45, 90 triangle. So I know my reference angle here is going to be 45 degrees. 45 and 45. So those two are 45 and 45 degrees. And just for fun, for shiggles, let's figure out what this side here. So this is 1. Oh, this has to be 1. And this has to be negative 1. Okay, so the question is basically asking what angle in standard position gives you cosine of that angle equals 1 over root 2. So really the question is, what is this angle? Well, it's 45 degrees. And what is this angle? Well, that one is 360 minus 45, which is 35, 315 degrees. So my answer is, or my answers are 45 degrees and 315 degrees. So if you punch this into your calculator, go cosine 45 degrees, you'll get 1 over root 2. If you punch in cosine 315 degrees, you'll also get 1 over root 2. Okay? Any questions? Yeah, I didn't think so. Okay, so I'm going to pause here and do the second one, and why don't you go ahead and try that and figure out which angles produce this. When you go tangent of that angle, gives you -1 over root 3. And remember, tangent here is negative, so it's not going to be quadrant 1 and 3. It's going to be in quadrants 2 and 4. So let's just pause here. And we're back. Okay, so I figured out, well, tangent is negative, so it has to be in quadrants 2 and 4. Okay, and then I drew the picture, so my reference angle is, I don't know yet. So all I know is that opposite over adjacent, right? This is opposite over adjacent, which is tangent. This is opposite over adjacent, is, well, 1 and root 3. Opposite over adjacent, 1 and root 3. And then I can figure out which one's negative, because in the picture, not all of these are positive. This one's positive, this one's negative. This one's positive, this one's negative. Okay, so then you look on your special angle triangles, and there's root 3 occurs only in the 60, 30, 90 triangle. So then, okay, I gotta figure out, okay, so is my reference angle 30 degrees or 60 degrees? So you kind of just think about it this way. Okay, well, here's root 3, and here's 90 degrees, and what's that other angle that's gotta be here? That reference angle. So I just kind of look on this 90 degrees, here's root 3. Oh, hey, this is 30 degrees. 30 degrees. And the reference angle here has got to be the same. Okay, so then the question then becomes, what are these angles in standard position? And that means you start off here. So the first one is from there to there. So that's 180 minus 30 degrees, which is 150. Okay, so 150 is one of the answers. And then the question is, well, what about the other one? This one here. That one is 360 minus 30 degrees, which is 330 degrees. Okay, so those are our two answers that will produce. Tangent of those two answers will give you -1 over root 3. Okay, one more question. One more. Just one more. Okay, so welcome back. So here, this is where you're going to have to break out those calculators, or I should say bust out those calculators, because you have to. Okay, so obviously 0.56 isn't something special from our special angles or quadrantal angles. So what you're going to do is you're going to solve for theta. So to get rid of sine, you have to do opposite of sine, which is sine inverse. You're going to go sine inverse of 0.56. So do this in your calculator and see what you get to one decimal place. I think one decimal place is good enough. Make sure you're in degree mode. Okay, so make sure you get 34.1 degrees. Okay, so you get 34.1 degrees, and that's where this ratio here, sine is positive, right? Sine is positive, so that means it's here and here, right? All and students. So that means this is 34.1 degrees, which I found one, and I got to figure out the other one. Well, this is 34.1, but what is this angle in standard position? Okay, so one of the answers is 34.1 degrees, which I don't need to write again. So let's figure out what is 180 minus 34.1. Whatever that is, that's your second answer. And I am looking for my answer. My answer is 145.9 degrees. Okay, so your two answers are 145.9 degrees and 34.1 degrees. Okay, that makes sense, right? Doesn't it? I think so. Makes lots of sense to me. Okay, and then part B, it says here that tangent theta, the ratio here is negative. And where is tangent negative? Well, let's do this whole thing again. All students take cookies. And tangent is positive here, here, A and T, so therefore it's negative here and here, so that's what we want. So I'm going to draw the pictures. And so somewhere, let's just do it like this. Okay, so let's figure out what theta is equal to. So using your thingamabobber calculators, so go inverse tangent of negative 0.85 shall yield, what does it yield? It yields negative 40.4 degrees. That's interesting. Well, take a look at this limitation here. It says that theta must be between 0 and 360. So I have to add 360 to this, right? Just circulate once around, go all the way around, just rotate once to get what is actually in standard position, and this is 319.6 degrees. So that's one of my answers. Okay, and let me just draw here, because negative 40.4, it's actually easy to draw here. It's like this. The reference angle is 40.4. Okay, negative just means it just rotates the opposite direction, so it goes clockwise. Yeah, clockwise. Okay, so if that's 40.4 and this is 40.4, then it's easy to figure out that second angle this way from angle in center position. So basically 180 minus 40.4 gives you 139 degrees, sorry, 0.6 degrees. So those are our two answers. Okay, so this lesson, except for example 3, you're able to pretty much figure out all these sine, cosine, tangent of all these special angles or quadrantal angles. So make sure you know these pictures here on the side. You can somehow derive these two triangles, and also remember these graphs so you can figure out sine, cosine, tangent of these quadrantal angles. And your homework, I will write it up shortly, so just give me 1 second. Ta-da! So there's your homework and quiz next day. Oh, and by the way, I drew a nice ice cream there for you. Isn't that nice? Okay, bye-bye.